This is a short video to show you how to solve the challenge problem that was in the classwork from Wednesday. We were asked to prove that the integral between a and b of the function x is b squared minus a squared over 2, and we'll do this by looking at the Riemann sums. So first what we'll do is we'll think about what delta x is equal to. That would be the width of each of our rectangles. That's going to be b minus a over n, using a and b as the lower and upper bounds. And then the height of each rectangle will be our lower bound a plus I times delta x. So we'll have a plus I multiplied by b minus a over n. This is a plus bi over n minus ai over n, just distributing that I. All right, and then the definition, we're going to be taking the limit as n approaches infinity of the summation as I goes from 1 to n of, we're taking x sub I and plugging it into our function, which is x. So we'll just plug that. That's going to be written as our function. So a plus bi over n minus ai over n. That's f of x of I. And then we multiply by delta x, which is b minus a over n. Or I'll write this as b over n minus a over n. I just want to separate this because now what I have to do is multiply all of these terms together. Okay, so we've got the limit and the summation. All right, and now I'm going to systematically multiply each of these together. So I'm going to pause for just a second. Okay, so I just went through and multiplied the first term by this, and then by this. That gave me these two. And then I repeated and did the second term multiplied by both of these, and that gave me this, and so forth. Okay, so that's everything multiplied out. And then what we'll do is we will combine things that are alike. So it looks like I can combine ab minus a squared over n. That's one. And then, let's see, b squared minus ab, actually, it'll be 2ab. These two guys are the same, right? These two are the same. Minus 2ab over n squared. Actually, I don't want the I there. I want to put the I on the outside because I know I want to factor that out eventually. So what I've done is I've combined these three. Actually, I can combine all four of those. Let's do that. Let's do all four of these guys together. B squared minus 2ab plus a squared all over n squared, and then we'll have this I on the outside. I'm doing that because I know I'm going to factor everything outside of the summation that I can. Okay. So let's split this up into two separate terms now. We'll have the limit as n approaches infinity. The first one, the ab minus a squared over n, that can all come out to the front because that first term doesn't have any i's in it. For the second one, we have b squared minus 2ab over n squared. And then this is the summation of I. Okay, so now we'll use the definitions for each of those summations. This changes to n. And this is going to change to n squared plus n over 2. Okay. For this first one, the two n's are going to cancel, and we have ab minus a squared. There are no n's involved in that, so we'll just end up with ab minus a squared. For the second term, I'm going to split up this fraction here so that I can distribute it to the fractions separately. And I'll do that right now. I'm going to rewrite this as n squared over 2 plus n over 2. So that way I can multiply it separately by each of these fractions. And you'll see why in a second. Actually, rather than write this whole thing out, when I multiply the first one, the n squared and the n squared is going to cancel. So I'm going to have that, it's just going to end up being b squared minus 2ab plus a squared over 2. All right, and when I multiply the second 2, I'm only going to have one of the n's cancel, and so I'll have plus b squared minus 2ab plus a squared. This will still be over 2n. The reason that this is significant and I want to do this separately is because we're taking the limit as n goes to infinity, and so this whole thing is going to approach 0 because I've got that n in the denominator. So now I really only need to consider this part, and since there are no n's in it, I can say that it's just going to be that b squared, let's write it separately, over 2 minus ab, and then plus a squared over 2. Now we're going to combine these two together because these are the two terms that we had. It looks like ab and ab are going to cancel, right? ab and negative ab are going to cancel. So let's see, I've got b squared over 2 plus a squared over 2. Let's write this as minus 2a squared over 2 so that all the denominators are the same. This is b squared minus a squared over 2. That worked out pretty nicely. All right, thanks for watching. Let me know if you have questions.